Well, scientists are predicting that a new ocean could be created as Africa gradually splits into two separate parts in the future.
Look at the left side of that image. It looks so clearly like massive amounts of water came over there and then pulled back. Like, look at the way it's eroded.
Joe Rogan has brought attention to a geological transformation of apocalyptic proportions. The East African Rift, a colossal fracture in the Earth's crust, is silently tearing the African continent apart. As this ominous process unfolds, it raises chilling questions. What does this mean for the future of Africa and its people? Are we witnessing the birth of a new ocean and a cataclysmic shift in the world's geography? Join us as we explore the terrifying truth behind Africa's impending split. From the dawn of human civilization, our understanding of the world has been shaped by the ever-evolving theories of Earth science. One of the most pivotal is the concept of continental drift, which posits that the Earth's continents have moved over geologic time relative to each other, appearing to have drifted across the ocean bed. This idea, first suggested by Abraham Ortelius in 1596, was later developed more fully by Alfred Wegener in his 1915 publication, The Origin of Continents and Oceans. Wegener proposed that the continents had once formed a single landmass called Pangaea before breaking apart and drifting to their present locations. However, at the time, this hypothesis was met with skepticism, primarily due to the lack of a convincing mechanism to explain these movements. It wasn't until the English geologist Arthur Holmes proposed mantle convection as the driving force behind continental drift that the theory began to gain traction. Continental drift theory, despite its initial resistance, has fundamentally reshaped our understanding of the Earth's geology. The notion that continents are not static but move continuously revolutionized the field of geology. It prompted a question: if continents have drifted, what forces could possibly be powerful enough to move such massive land masses? And as Joe Rogan uncovers the phenomenon of Africa's division, what new insights might we gain into the forces that shape our planet? The answer to this question begins with the complex dynamics occurring beneath the surface of the Earth. The Earth's outer shell, the lithosphere, is not a single, unbroken shell. Rather, it's composed of several large tectonic plates. These plates, some carrying continents, others ocean floors, are not fixed. They float on the semi-fluid asthenosphere beneath. This movement is not random but is driven by the dynamic nature of the Earth's interior. Think of it as a slow, churning dance of giant rock slabs on a global scale. But what causes these plates to move? It all comes back to the heat deep within the Earth's core. The Earth's interior is incredibly hot, with temperatures similar to the surface of the sun. This intense heat generates convection currents within the asthenosphere. These currents of hot plastic rock slowly rise and fall, pushing and pulling the tectonic plates above. This process, known as mantle convection, is akin to the boiling water in a pot, where heated water rises to the surface, cools, and then sinks again. But in the Earth's mantle, this happens at a much slower pace. Have you ever wondered why the Earth doesn't just cool down and solidify completely? The continuous decay of radioactive elements within the Earth's core produces heat, sustaining these convection currents. This revelation was monumental, but there was another piece of the puzzle. In the 1960s, scientists discovered the mid-ocean ridges, mountain ranges under the ocean where new ocean floor is created. They noticed that the ocean floor's age gets older the farther it is from the ridges. This led to the development of the theory of seafloor spreading. As magma rises at these mid-ocean ridges, it cools and solidifies, forming new oceanic crust. As more magma rises and cools, it pushes the older crust away from the ridge, causing the ocean floor to spread. But where does the old ocean floor go? The answer is subduction zones. These are areas where one plate is forced beneath another, driven back into the mantle where it melts. It's a continuous cycle of creation and destruction. This cycle of creation at mid-ocean ridges and destruction at subduction zones is integral to the movement of continents. As oceanic plates move, they carry continents with them. This explains why the Earth's continents seem to fit together like pieces of a giant puzzle. Take, for instance, the coastlines of South America and Africa. Their contours match so closely that it suggests they were once joined. This was part of Wegener's initial evidence for continental drift. You might be shocked to know that the movement of continents isn't just a thing of the past. It's happening right now. The African continent, for example, is currently in the process of splitting into two. The East African Rift, a massive crack in the Earth's surface, is slowly tearing the African plate apart. This rift is a direct manifestation of tectonic forces at work. It's a process that takes millions of years, but eventually, a new ocean will form, splitting Africa into two separate continents. This slow but relentless movement challenges our perception of the Earth as a static and unchanging entity. The East African Rift System is one of the planet's most striking geological features. Stretching over thousands of kilometers from the Afar Triple Junction in the north to Mozambique in the south, it is a vivid example of active continental rifting. But what exactly is the East African Rift, according to Joe Rogan, and how did it come to be? The formation of this rift, a slow yet monumental process, has been occurring over millions of years, marked by the stretching and thinning of the Earth's crust. This process, known as rifting, is a prelude to the creation of a new ocean basin, reminiscent of the birth of the Atlantic Ocean millions of years ago. This massive rift system is a series of geological faults and valleys, where the African tectonic plate is slowly splitting into two separate plates, the Nubian plate to the west and the Somali plate to the east. The forces driving this split are the same mantle convections that have shaped the Earth's surface for billions of years. The Nubian plate, making up most of Africa, and the smaller Somalian plate are moving away from each other and also from the Arabian plate to the north. This movement is centered around the Afar region of Ethiopia, forming a triple junction, a point where these three plates meet. But the rifting activity is not confined to the Horn of Africa. It extends south into Kenya, Tanzania, and the Great Lakes region of Africa, making the geology of these rifts an intriguing subject for scientists. But what propels these massive slabs of the Earth's crust to move? Enter mantle plumes. These are upwellings of hot, buoyant rock from deep within the Earth's mantle that rise towards the surface. Imagine a lava lamp, with blobs of hot wax rising and falling. This is similar to how mantle plumes behave, but on a colossal planetary scale. When these plumes reach the lithosphere, they exert pressure from below, causing the overlying crust to bulge, weaken, and eventually fracture. This process of lithosphere stretching and breaking is precisely what's happening in the East African Rift. The heat and dynamic pressure from a mantle plume are thought to be key drivers behind the rifting process. Historically, the discovery and understanding of the East African Rift have been a journey of scientific intrigue and exploration. Initial observations of the rift were made centuries ago, but it was not until the 20th century that the significance of this vast geological feature was fully recognized. Geologists, intrigued by the unique landscapes and volcanic activity in the region, began to piece together the puzzle. But what does the current state of the East African Rift tell us about the future of the African continent? The rift is not just a static feature, it's a dynamic and evolving system. The process of rifting is ongoing, with new cracks and fissures appearing regularly. The movement of the Nubian and Somali plates is slow but relentless, averaging a few millimeters to a few centimeters per year. In geological terms, this might seem insignificant, but over millions of years, it amounts to a dramatic reshaping of the continent. But the East African Rift isn't a solitary case. Our planet's surface is etched with rifts and fractures, each with its own unique story. Take, for instance, the Mid-Atlantic Ridge, a monumental underwater mountain range that runs down the center of the Atlantic Ocean. This ridge marks a site where the Eurasian and North American plates are moving apart, creating new oceanic crust. Another striking example is the Great Rift Valley in Jordan, part of the same rift system as the East African Rift. But what other secrets might Joe Rogan reveal about these mysterious fractures beneath our feet? In this context of continuous geographical transformation, Joe Rogan's voice has stood out in bringing these wonders to the mainstream. On his widely followed podcast, the comedian and UFC commentator has delved into some of the most captivating geological mysteries of our time. One such enigma, deeply connected with the story of the Earth's rifts, is the legend of Atlantis. According to the myth, Atlantis was not just a city, but an empire comprising 10 kingdoms, with a capital made up of concentric circles of land and water. This description strikingly resembles the Richat structure in the Sahara Desert, suggesting that this geological marvel could potentially be the site of the lost city of Atlantis. As Rogan and his guests discuss the dynamic nature of our planet, it's fascinating to draw parallels with the East African Rift. The Richat structure, also known as the Eye of the Sahara, is approximately 40 kilometers in diameter and displays sedimentary rock layers in concentric circles. Interestingly, satellite imagery shows evidence of water flow through this structure, supporting the theory that it might have been connected to the sea. Both the Richat structure and the East African Rift can be considered testaments to Earth's capacity for dramatic change over time. Moving from the mysteries of Atlantis to the wonders of ancient Egypt, Rogan's podcast also sheds light on the advanced technologies that might have been employed by the ancient Egyptians. The presence of machining marks and stamps on Egyptian structures indicates the use of advanced drilling tools capable of penetrating granite. This revelation challenges our understanding of historical technological capabilities and suggests that the ancient Egyptians were far more advanced than previously thought. Perhaps these ancient civilizations had a deeper understanding of the Earth's geological processes, which might shed light on the current transformations we observe in the East African Rift. Rogan's conversations often circle back to the idea that there is much about our world and its history that remains unknown or misunderstood. The East African Rift, with its geological significance, could very well be a part of this larger, mysterious narrative of our planet's past. In this context, the rift isn't just a geological feature. It's a piece of the puzzle in understanding the Earth's evolutionary story and the civilizations that once thrived alongside these changing landscapes. Nowhere is this more evident than in Kenya's Great Rift Valley. This vast geographical and geological feature, a series of interconnected rifts in the Earth's crust, stretches across East Africa from Mozambique to Syria. It is known for its stunning scenery, abundant wildlife, and rich cultural heritage. Formed by the movement of several tectonic plates, the Rift Valley is characterized by deep troughs, steep cliffs, highlands, valleys, lakes, and volcanic features, creating a landscape ranging from lush forests to arid deserts. But what does this mean for the Earth and its inhabitants? Recently, there have been significant geological activities that not only affirm the ongoing dynamics of the rift, but also reshape the landscape. Examples include the emergence of new volcanic activity, the opening of fresh fissures, and the shifting of Earth that occasionally rends roads and homes. In 2018, a large crack appeared in Kenya, a startling reminder that the Earth beneath our feet is continually moving. This phenomenon is not merely a spectacle. It holds profound implications for the future geography of the continent. Additionally, over the past decade, there has been a significant rise in water levels in the Rift Valley's lakes, including Lake Baringo and Lake Bogoria. The rising waters have submerged roads and homes, displacing communities and altering the local way of life. But thousands of years ago, the water levels in this region were much higher, indicating that the current changes are part of a long-term climatic and geological cycle. The interaction of tectonic activities and human-induced environmental changes is reshaping the Rift Valley, posing challenges for food security, water availability, and overall biodiversity in the region. This dramatic transformation of the Rift Valley has profound implications for the surrounding nations, particularly landlocked countries like Zambia and Uganda. The possibility of these nations gaining coastlines due to the rift's progression is a scenario that, while distant, could have significant socioeconomic and environmental consequences. This potential development could revolutionize trade and economic opportunities for these countries. providing access to maritime routes and resources previously unattainable. The advancements in technological tools have been pivotal in monitoring and understanding the changes occurring in the East African Rift. Satellite imaging and radar technology have enabled scientists to capture detailed images of the rift, revealing the nuances of its movements and developments. This technology provides a bird's-eye view of the vast geographic area, allowing for precise monitoring of changes over time. The use of radar, especially synthetic aperture radar, has been instrumental in detecting ground movements, even those as subtle as a few millimeters. In addition, GPS measurements have become an essential tool in geophysical data analysis. By setting up GPS stations along the rift, scientists can measure the rate at which the African continent is splitting. These measurements provide valuable data on the speed and direction of tectonic plate movements, helping in predicting potential seismic activities and volcanic eruptions, which are key aspects of the rift's dynamics. As we look to the future, it is clear that the ongoing transformation of the East African Rift will have far-reaching effects, not just geologically, but also socio-economically and geopolitically. The need for proactive planning and international cooperation is paramount to ensure that the opportunities and challenges presented by this natural phenomenon are managed effectively and equitably. As we peer into the future of East Africa, shaped by the ongoing activities of the East African Rift, we find ourselves on the brink of a geological mystery that could dramatically reshape the African continent. In the next millions of years, as the rift continues to evolve, the changes it brings could be nothing short of extraordinary. Geologists predict that if the rifting continues at its current pace, it could eventually lead to the formation of a new ocean. Imagine a future where the waters of the Red Sea and the Indian Ocean merge, filling the widening gap created by the drifting apart of the Somali and Nubian plates. This monumental geological event would forever alter the map of East Africa. The formation of a new ocean within the East African Rift is not a mere hypothetical. It's a geological process already underway. One striking evidence of this ongoing transformation is the volcanic activity at Erta Ale, a shield volcano in the Afar region of northeastern Ethiopia. Erta Ale, known for its persistent lava lake, is one of the few volcanoes in the world with an almost permanent lava lake, making it a unique site for geological study. This volcanic activity is a direct consequence of the tectonic movements beneath the Rift Valley. The intense volcanic activity at Erta Ale and its surrounding areas is intricately linked to the formation of a new ocean. The constant upwelling of magma at Erta Ale indicates the thinning and weakening of the Earth's crust in this region, a precursor to the splitting of the continental plate. As the Nubian and Somali plates continue to move apart, the thinning crust could eventually rupture, allowing seawater to flow in and form a new ocean. This remarkable geological shift, however, is not just about the visible changes on the surface. It opens the door to a realm of speculations and theories, particularly about what lies beneath, the possibility of hidden civilizations and unexplored geological features within the depths of the Earth beneath the rift. Among the various theories that have surfaced, one particularly intriguing idea is the existence of a secret underground world beneath the rift. This theory posits that hidden civilizations could lie in vast caverns or networks beneath the Earth's surface, directly beneath the rift itself. These speculations draw from a myriad of sources, including ancient myths and legends from various cultures that speak of subterranean worlds inhabited by advanced civilizations. These stories often depict underground realms as places of great wisdom and advanced technology, hidden away from the surface world. In African mythology, for instance, there are tales of underground kingdoms rich in gold and precious stones, guarded by powerful beings. Could these tales be mere folklore, or do they hold some truth about what lies beneath the rift? However, alongside these mythical narratives, there exist theories in the realm of modern conjecture that suggest more tangible, albeit controversial, explanations for the East African Rift's formation. Some theorists propose the idea of hidden geoengineering projects as the driving force behind the rift. These theories suggest that large-scale engineering efforts, possibly undertaken by international organizations or governments, are manipulating the Earth's geology on a massive scale. The basis of such theories lies in the belief that technological advancements have reached a point where influencing tectonic activity is within the realm of possibility. Proponents of this view argue that the rift's rapid development and the unusual geological activities observed in the region are too synchronized to be natural occurrences. They speculate that these geoengineering projects aim to control natural resources, alter weather patterns, or even conduct experiments in tectonic warfare. Thanks for watching this episode of Beyond Discovery. Don't miss the video you see on your screen, you won't believe it.